So our learning target, again, is always up here at the top of your notes. It is also always going to be on your Google Classroom. I can apply the properties of multiplication to solve our rational number multiplication and division problems. So you'll notice our properties, the terminology for our properties looks the same as what it did with addition. That's because addition and multiplication both are able to utilize associative properties, commutative properties, and identity properties. Remember, with addition, the identity property focused on 0, that anytime you added 0 to a number, the number remained unchanged. It kept its identity. For multiplication, our identity properties are going to be both out of values of 1, an identity property of 1, and an identity property for 0, or the 0 property. So for identity properties, in order for a number to keep its identity, what would you have to multiply it by so that it remains unchanged? Montserrat? 1. We would multiply by a value of 1, it keeps the value completely unchanged. With the 0 property, this means that any number that you multiply by the value of 0 is always going to yield what value? 0. Thank you, Hassan, for raising your hand. Okay. With our associative property, remember with associative property, I told you guys to think of it kind of like who you group yourself with, who you associate yourself with. What is written inside of your grouping or your cluster is able to change. What was inside can move to the outside. What was outside could be changed to the inside of your grouping or clustering because your association can change. So the same thing for multiplication occurs, that what you have on the inside can change from one problem to the next and still yield the same answer. So previously we have 3 times 4 that we're saying, hey, we got to do this first. We have to multiply 3 times 4 first based off of our property or our PEMDAS, our order of operations, and then we'll multiply that product by 2. Or we could reverse it. We could go ahead and multiply 4 times 2 first and multiply that product by 3. They both are going to give us the same answer. Our commutative property, with commutative property, the order is going to change. So 3 times 4 is the same thing as 4 times 3. Your grouping is just formatted differently. Remember back in 3rd grade, you guys learned how to discuss what multiplication's read as. We don't just say 3 times 4, we say it's 3 groups of 4. Or 4 groups of 3. They both are going to provide to you the same value. And I gave you guys some picture representations so you could see that. When we say 3 groups of 4, I have 3 separate groups of 4 dots in each group, yielding your 12. Here I have 4 groups of 3, meaning that I've got 3 dots for each of my 4 groups, still giving you 12. It does not matter the order that you multiply. You can reverse the order. It still provides the same. Now here's one that some of you may or may not have heard of. Raise your hand if you've heard of distributive property. Okay, so a few of you. We're going to heavily use distributive property, especially when we get into our expressions and equations unit. For what you're seeing right here is just a representation in number format, where we're saying, okay, if we've got 4 times a sum of 1 plus 2, what this means is I've got, and I tried my best to represent it visually, I've got my sum, which is a 1 plus a 2. So if we do 1 plus 2, how many dots should that be? 3. But I tried to separate it. I've got 1 dot, and then I've got 2 dots, and I've got 4 of those groups that have 1 and 2 dots in each. So it comes out to the same value. It's still going to come out to 12. What distributive property does is it takes multiplication of a sum and it breaks it up into the sum of 2 products, 2 smaller products. So instead of adding these together and then multiplying what's on the outside, we're distributing it by going, okay, we're going to do 4 times the first term, 4 times 1. So I have 4 groups of 1. And then I'm going to multiply 4 times my second term, 4 times 2. So I have 4 groups of 2. And then when I combine all that together, it's still going to give me the same amount of dots. I still have 12 dots. So it comes out to the exact same value, whether you distribute ahead of time or you don't. Now, when it comes to algebraic expressions, distribution is going to be required to happen first because you cannot combine x and a number together. Like x plus 7 is just x plus 7. So you would actually have to do your distributive property first. Okay, any questions about these properties so far? All right, let's take a look at our inverse property. The inverse property of multiplication. That means that if you take a value and multiply it by its inverse, its reciprocal, then it's going to yield to you the value 1. Okay, so for this example, I have a times 1 over a, or you could write 1 over a times a. It doesn't matter how you write it, it's still going to come out to 1. It's the same thing here. If we had a 5 and multiply it by 1 over 5, it's going to come out to a 1 because 5 over 5 would equal 1. If you had negative 3 and 1 over negative 3 and you multiply those together, those inverses, it's going to come out to 1. The only situation in which it would not come out to 1 is if you have a 0 involved. The reason being is you cannot have 0 in your denominator. 0 is not allowed in the denominator. It would provide to you an error message, which we'll learn more about what that message actually means when we get into functions next semester. Okay? So the reason your inverse property is so important is because when we perform division problems, we're actually doing the multiplicative inverse. We are actually taking this 4 and multiplying instead of dividing. So we're multiplying by its inverse, 1 over 4. Any questions? Okay, what I want you guys to do is flip it on over to the back. You're going to see a problem that has been worked out, and what I want you to do is, based off of each of the steps, identify what property potentially was used. And I want you to take your highlighter and highlight where you saw the property happen. So let's do this first part together. Here's our original problem. Our original problem is 8 divided by negative 2/3 times 7 divided by negative 2 times negative 3. When we get to step 1, who can tell me where should I highlight that a change occurred in the problem? Okay, so right here we see a change, and I'm going to highlight the fraction as well, because did the fraction stay the same? No. Anywhere else that I see a change in the problem? Logan? Yeah, so the other division of negative 2 now became multiplying by 1 over 2. And I just realized that this one doesn't have the negative sign. So we're going to go ahead and pretend that this was a positive sign instead of a negative, just to keep it consistent. So what property does it follow when we changed the division into multiplication and we did the reciprocal? What property did I just showcase there? Look back at your property sheets. What property did we do that says division can change to multiplication and we can flip it? The inverse, our inverse property of multiplication, or the multiplicative inverse. That's what we'll call it. So all we did here, multiplicative inverse, is we went ahead and changed division to multiplication, and we did the inverse of our value, which is to find the reciprocal. Okay, so I want you guys to finish off the rest of this. You're going to highlight where you see a change, where something is different, and indicate what property do you think was utilized to get there. All right, let's go ahead and discuss. So who can tell me what should I be highlighting in step 2? Where did a change occur for step 2? Actually, I'm just going to go ahead and call on people. So if I call on you and you get it correct, wonderful, you'll get your points for today. Let's go with Mario. What should I be highlighting here? Okay, negative 12. And what happened that caused us to get negative 12? What did we do? What process did we do to get to that negative 12? Let me see here. Let's multiplication. All right, so all we did is we multiplied. We just multiplied 8 times the negative 3 over 2. 8 times negative 3 over 2 is going to give us that negative 12. All right, when we go to step 3, let's go ahead and call on Maggie. Maggie, what is different? What changed here in step 3? You can use your hands to symbolize it if you want. No? Okay, let me call it here. How about Kai? Can you tell me? They grouped, right? They made a grouping. They put these little brackets or these parentheses of some sort around this value here. So we now have the creation of a grouping. So when we create a group, when we've created a group, what property is that called, Hassan?
Associative property.
Associative property. So we've now used the associative property. Okay, we've created a grouping around negative 12 and that 1/2. All right, step 4. Step 4, what happened? Let's see here, how about Tiffany? Step 4, what should I highlight? What's changed from step 3 to step 4?
The -6 is in step 3.
Very good. All right, so we now have a value of -6 because from step 3, we went ahead and multiplied, right? We multiplied the values that we put into our clustering, into our grouping. We did negative 12 times that 1/2, and that gives us that -6. Okay, from here, what changed? Logan?
They multiplied 7 times -3.
They multiplied 7 times -3. Based off of order of operations, are we supposed to do 7 times -3 first? Yes or no? No. Order of operations says we have to multiply from left to right, but we multiplied out of order. What property allows us to do it in a different order? What property allows us, Merrick? Commutative property. The fact that we did 7 times -3, we utilized commutative property. It let us multiply in a different order. Okay, and then our last step, again, very simple. We now have a positive 126 because all we did was multiply. Okay, so it's a very easy process. It's a long problem, but it's very easy to identify your properties if you go back and start highlighting where did the change occur. Okay, what did they do that created that change? When you break it down step by step, it's a lot easier. It can look real daunting, guys, if you look at it like this and then you're like, oh, I have to give all this justification. But if you take your time and just highlight or circle where you see the change and just focus on that part, it's real simple. Okay? All right, so let's take a look now at the bottom set of problems where we're going to be using the distributive property. Now, it might not look like distributive property for these first two, but we actually are going to showcase distributive property because remember last week we learned, in fact, let me see if I can pull up the notes from last week. Where are they? Here we go. Last week we talked about how you can break apart a mixed number by saying the opposite of a sum is the sum of its opposites. So a mixed number is a sum that we are breaking apart into its whole number and fraction portion. We're going to do the exact same thing here for distributive property. And that makes it easier to be able to multiply when you have a whole number and a mixed number and you're not allowed a calculator. So those of you who have your calculators right now, I want you to take it and flip it upside down so that you're not tempted to use it. Okay, yep. This will be fine. So let's take a look here. We have negative 10 times the mixed number 2 and 3/5. What I'm going to do is I'm going to break this apart. I'm going to take my negative 10, and then it's going to be on the outside, and I'm going to pull the 2 and 3/5 apart. I have a 2 and I have a 3/5. So I've got 2 plus 3/5. That's all you're doing to break it apart. You're separating it out that way. Fatima, close the computer all the way now. Thank you. Now from here, we're going to use our distributive property. The distributive property indicates that you are multiplying each of your terms on the inside of your parentheses by the value that's on the outside. We're taking the sum and breaking it up into small products. So we are multiplying 10 or negative 10 times 2. And then we are also multiplying negative 10 times 3/5. Okay, so that's not so hard to do. And we'll put our plus sign in between. Now, negative 10 times 2, those are whole numbers. We have a negative times a positive. A negative times a positive is a negative. And what is 10 times 2? Go ahead. Negative 20. So we're going to get negative 20 here. Now with our fractions, when we multiply, we like to make sure that everything is in fraction form. So I'm going to put negative 10 over 1. And then I'm going to multiply straight across. What is negative 10 times 3? Negative 30. And what is 1 times 5? That's going to be 5. And if we have negative 30 over 5, can you divide negative 30 over 5, Fatima? Negative 6. So this now comes out as plus negative 6. And you can add those. What's negative 20 plus negative 6? Negative 26. Okay? It's not that difficult to do. Negative 26. Okay? For the second problem, and I'll do that in a different color. Richard, I need you to... I understand, but sometimes maybe she should just ask me first, okay? For here, for the second problem, I'm going to break this apart. I've got a negative 14, and I'm going to break apart my mixed number. What's the first value I'm going to write, Lucas? Not just 3. Negative 3. And then I'm going to put my little addition. Remember, the opposite of the sum is the sum of its opposites, so we have to write it as an addition. It's a sum. What's my fraction going to be? Logan? 5/7. Not just 5/7. Negative 5/7. Okay, when you're breaking them apart, the negatives have to attach to both of them if you're pulling them apart. If you're looking at it as a whole, you only are required to have one negative, but when you split it up into its sum, both of them are negative values. And now we go ahead and distribute. You guys can do the distributive property on your own right now. Go ahead and try that one on your own. Let's see how you do. So the first thing that we're going to do is we're going to multiply. We're going to do negative 14 times negative 3. Negative 14 times negative 3, since it's two negatives, it's going to come to a positive. 14 times 3, Montserrat? 42. Very good. So we're going to get a positive 42. Then we're going to multiply. We're going to have a negative 14, and we're going to multiply that by a negative 5 over 7. I'm going to show you guys a trick. You can simplify ahead of time. Let me zoom in ahead of time for here. You can simplify before you multiply. So remember, when you're simplifying fractions, you simplify it as a numerator over denominator. With multiplication, it does not matter which numerator and which denominator, as long as one of them is a numerator and the other is a denominator. So technically, I can simplify negative 14 and 7. I don't have to multiply negative 14 times negative 5 and then try to simplify it by a 7. 14 over 7 can simplify ahead of time already. Both of them are divisible by 7, so I can cross off the 7. 7 divided by 7 is 1. And what's 14 divided by 7? 2. So we have a negative 2 here. Then I can go ahead and multiply straight across. Both of these denominators happen to be 1s, so I'm technically going to have a whole number answer. What's negative 2 times negative 5? 10. So we now have 42 plus 10. That comes out to 52. So you should have gotten 52 as your answer. Let me just show you another example real quick of what I just did for simplifying. Okay, so let's say that we have something like, I don't know, we'll say 3 over 7, and I'm wanting to multiply it with, we'll say 14 over 9. 3 over 7 times 14 over 9. So 3/7 can't be simplified. 14 over 9 cannot be simplified, but 3 and 9, they can be simplified. What are 3 and 9 both divisible by? Logan? 3. So if I divide 3 by 3, it becomes a 1. If I divide 9 by 3, it becomes a 3. 7 and 14 can also be simplified. They are both divisible by what? 7. If I divide 7 by 7, that becomes a 1. And 14 divided by 7, that becomes a 2. So now my new fractions are 1 over 1 times 2 over 3. Let me do one more example. Let's say that we have 8 over 15, and I want to multiply it with, we'll say 5 over 14. Okay, 8 over 15 times 5 over 14. Again, the fractions themselves cannot be simplified, but if you're looking at the numerator and denominator across from each other, they can. Okay, 8 and 14, they both can be divided by what value, Hassan? 2. 8 divided by 2 is going to become a 4. 14 divided by 2 is going to become a 7. What about 15 and 5? What are they both divisible by? Jeffrey? 15 and 5? What are they both divisible by? 5. Okay, 5 divided by 5 becomes a 1. 15 divided by 5 becomes a 3. So here's your new fractions. 4 over 3 times 1 over 7. Now that you simplified ahead of time, when you multiply, it'll already be in its simplest form. Okay? Makes it a lot easier when you're working those problems out. So let's go back to here. We're just going to do one more example right here, and then I'm going to let you guys have on to your Delta Math. Okay? So for this problem, again, we've got a fraction on the inside that needs to be distributed to both components that are, a fraction on the outside to get distributed to both components on the inside. So we're going to do negative 5 over 7, and we're going to multiply it by a 10. Then we're going to do negative 5 over 7, and we're going to multiply it by a negative 1 over 5. Notice I went ahead and changed this to a plus and then kept the 1/5 as a negative. I'm just assigning that minus sign to my fraction and keeping this as a sum instead. Okay, negative 5 over 7 times 10, it's technically 10 over 1. Can you cross simplify at all? Yes or no? No, right? 5 and 1, that's already simplified. 10 and 7, that's already simplified. So we're just going to multiply. That becomes negative 50 over 7. Plus, for here, we have negative 5 over 7 times negative 1 over 5. Can we cross simplify anything? Yeah, what can we cross simplify? The 5s. Both of the 5s are divisible by 5. And so they will become 1 and negative 1. Okay, so we now have negative 1 over 7 times negative 1 over 1. What's a negative times a negative? Positive. And then when we multiply, it's just 1 over 7. So we have a negative 50 over 7 plus a positive 1 over 7. They are like denominators. They are like denominators. So we can go ahead and just combine the numerators. Negative 50 plus 1 is negative 49. So we get negative 49 over 7. Can we simplify that? Yeah. Negative 49 is divisible by 7. What does that become? 7. Negative 7. Okay. What I want you guys to do right now is you're going to log into Google Classroom. And you're going to see a Delta Math link. Remember, you log into Delta Math using your Google student account, and you'll work on the problems that's associated to that account.